In this problem, we have to count the number of ways of reaching from bottom of a stair to top of a stair. And there are different steps in the stair. And in each step, you can either climb by 1 or 2. So you have to just return in how many ways you can do that. So let's look at an example. So this is a pretty simple problem. So if you have done Fibonacci sequence, then this should be very similar to that. So let's take a stair of just 4 steps. And let's level them 1, 2, 3, 4. And we have to reach from here till top. So what we can do, one would be to take one step at a time. So go 1, 2, 3, 4. That is, you jump to first step, then second, then third, then fourth. This is the first way. Next, we can reach the last step from 3 as well as 2. So 3 by taking one step, 2 by taking 2 steps. There is no other way. And let's say you came to 2 following one step each. So what is this one? From 0 we went to 1, from 1 we went to 2, and from 2 we went to 4. This is another way. Next way would be to take the first step, 2 step. So here in both these methods, we are going from 0 to 1, but we can go to directly 2 also. So we jump to 2, and from here there are more choices. We either go to 3 then 4. So let's do that first. 3 then 4. So this green will correspond to first we go to 2, then 3, then 4. Next, what else we can do? We can go to 1, then 3. So come to 1, then 3, then 4. So this is also valid. So how we are solving this? So let's say we are solving for some general stair. So in this case, we are solving for 4. We always start from bottom. So let's say we are solving for 10. So the 10th, we can reach the 10th stair. Let's say 10th stair is somewhere here. There are some more steps. This is the 10th step. So either we would come from this 9th one, or we can come from this 8th one. These are the only 2 values allowed. You can take either 1 step or 2 step. So if you know how many ways to reach from 0 to 8, then you can just take 1 step and reach 10. So this is same as count 8 plus, and you also know how many ways are there to reach step 9 from 0. Then you can take 1 step to reach 10. So if you add these two, you will get the solution. So this is very similar to Fibonacci. Fibonacci nth number is Fibonacci of n minus 1 if you take it as a function, plus f of n minus 2. So here also we are same. This this is n, this is n minus 2, this is n minus 1. But if we do it recursively like this, then let's see the recursion tree. For 10 we need 9 and 8. So we will solve for 10, 9 and 8. For 9 we will need to solve for 8 and 7. Here we will solve for 7 and 6. Then we will solve for 7 and 6. And 6 and 5. 6, 5, 5, 4. And it will keep growing. So first level 1, next level 2, 4, 8, 16. So in general, 2 raised to the power level number k, where k starts from 0. So it's exponential, and if you are solving it again and again, even for moderate values like 20, 30, this will become very, very slow and it may stop working. And other thing is that you are resolving it. For example, 7 and everything below it, you have already solved here. Similarly, 8 and everything below it, you are solving it again here. So we are resolving this problem again and again. Similarly, 6 and below, 6 and below. Here also 6 is there, here also 6 is there. So once you have solved it, no need to solve again and again and again. So this falls under the category of dynamic programming, that is overlapping overlapping solutions here, and optimal substructure. That is, in order to solve, if you solve the smaller problem in an optimal way, then you will solve the bigger problem. So n we broke into n minus 1 and n minus 2. So if you find the optimal solution of n minus 1 and n minus 2, which are less than n, then you will get the optimal solution of n simply by adding them. So what we will do here, we will start from the base case. If n is 1, then there is just one way. You have one stair and you have to reach from here to here. You will take one step. If we have two steps, then you can go one at a time, or you can directly go here. There are only two ways. And from 3 onwards, what we will do, we already know 1 and 2. So we can keep two values, x equal to 1, y equal to 2. And if n is less than equal to 2, and n is guaranteed to be at least 1, this is not 0 or negative, it's mentioned. So if n is less than equal to 2, you return n. And if n is more than 2, you return the previous two values. So for 2 it will be 1 plus 2, that is 3. For 4 it will be the solution for 3 and 2, that is 5. So here we had missed one solution. There would be one more solution here. You can try out that. For 4 it should be 5. For 5 it will be the solution for 4 and 3, that is 8. For 6 it will be 13. So these are in fact the Fibonacci numbers themselves. And we only need to keep track of previous two values. So we can start from this, and when we calculate 4, x becomes this, the corresponding to 3, and y becomes 5, the latest one. Then we are solving for 5. We will simply add them, so we get 8, and we update them. So y takes the latest value, that is 8, and x takes the value of whatever y was taking. So we are in kind of also doing sliding window. So we are keeping track of these two to solve this one. When we have solved this one, we slide this window to here. So the first one is x, second one is y. So when we slide here, this becomes x, this becomes y. Again we will move it here, and this will become x, this will become y, and so on. So let's write the code for this. And we are starting from 3, since if it's less than 2 or 2, we will return from here itself. So y will become y plus x. So x plus y is the next solution. So next solution we keep in y. So that's why we stored y here, since y is updated, and x will take the value of previous y, that is TMP. And finally we can return. So if we are doing less than n, then we will return x plus y. If you are doing till equal to n, then you will just return y. Both are valid. And the solution is accepted. And what will be the time complexity? It will be O of n, since we are just iterating from you can say from 0 to n. So there are n iterations, or n minus 2 iterations. So O of n, in a space we are having a few variables, so O of 1. So we can write the same logic in Java. And the solution is accepted. Finally we will write it in Python. or we can write x y equal to x takes the value of previous y and y takes the value of x plus y. And the Python solution is also accepted.